Thus far is we've been factoring binomials, which are like 2. We've been looking for greatest common factor, and then we've been looking to see if there's a difference of perfect squares. We have also worked with groups where we're grouping because we had 4. Well, now we're going to back up and deal with 3. So we're going to factor trinomials. Today, the lead coefficient is 1. First, what's a coefficient?
The number. The big letter.
All right, well, be a little more specific because we have exponents and we have
The number in front of the variable.
number in front of the variable. Excellent, Parker. So also, we need to reference standard form.
It's really hot. Yeah, it is.
Yeah,
I'm
it is.
sweating.
Well, the last class was really freezing.
I'm sweating like
Nicole
cold.
Fourth period.
There, that should be better. All right, so standard form. You need to be sure before you start working any of them that you're in standard form. Because if you have it mixed up, it's not going to work. So it's capital A, x squared, plus capital B, x, plus C, capital C. Your capital letters reference numbers, where A and B would be coefficients, but C would be a constant, doesn't have a variable with it. Now, of these, what would we call the lead coefficient?
Oh, the x squared. Or the a.
The A, the number in front of the x squared. All right, and that's going to be, and the reason it's the lead, it's the very first one. So, what we're working with today, the lead coefficient will always be 1. We will move into more complicated ones when it's not 1. All right, it'll be larger than 1. But we're going to get to the point of figuring out what to do when it's just 1. So, remember this. Foil. What is that?
First, outer, inner, last.
First, outer, inner, last. What operation do we use when you're foiling? Multiplication. All right? That basically what we're going to do is you're figuring out what the factor would be for these, which is like going backwards. We're going to figure out what was foiled to create this trinomial. Your trinomial is normally what you get when you foil. So last. What is that?
The last two numbers in the parentheses.
All right, so the last 2 numbers in our parenthesis. And in this case, and it's we get it by multiplying. And in this case, for our first problem, what is our last?
6.
It's a 6, a positive 6. All right, when you're multiplying, how do you get a positive number?
Multiply it by.
Same signs.
Same signs.
Wait.
2 negatives multiplied together will give you a positive. And then, of course, 2 positives would give you a
Okay,
positive.
yeah.
All right, does that make sense? All right, so we know that we're going to work with factors of 6. And I'm just going to list in order. So we're going to have 1 and 6, and then we could have 2 and 3. And then, of course, it starts over, like 3 and 2 and 6 and 1, and so you don't have to list those. So, the middle number is created using the outer and inner and normally combining them because they, most of the time, create like terms. Okay? Does that make sense? All right. So, what we're going to ask ourselves for this one. The last operation sign is a plus, which means it's either 2 positives or 2 negatives multiplied together to get 6. To know which type of sign it was used, you look to the first sign. It's also a plus. Therefore, we know it's 2 numbers that were positive being used. We can go ahead our first. We could say that it's x and x, to get the x squared. Now, here's the cool part. Two factors that equal 6 that when you add, you get 5. Here are our factors. Which one equals 5?
2 and 3.
X plus 2, x plus 3 will be your answer. So when you FOIL that to check it, you get an x squared. Outer gives you a positive 3, x. Inner gives you a positive 2x. And last gives you your 6. And then you add those together, and that gives you the 5x. Does each step make sense? So, you do number 2. And I'm going to write the factors of 8. We could have 1 and 8. What else could we have?
2 and 4.
2 and 4. And 3 doesn't go, and then we start repeating with 4.
So for the next one, for number 3, would you do 1 and 16?
I'm not there.
You do 8 and 2.
So what would you get for number 2?
X plus 2 and x plus 4.
X plus 2, x plus 4. Now, these are both factors that are being multiplied together. The parentheses are. So you could have x plus 4, x plus 2. The order of that will not matter. All right? As long as what you have in the parentheses match. Now, number 3, look at our last sign. It's a plus. So we know we're going to be using same signs. But when we look to the first sign, what does it tell you we're going to use? Negative. So this time they'll both be negative. Which means we're still doing what operation for outer and inner?
FOIL.
Well, what operation? If the signs are the same, what will we do with outer and inner? Outer and inner. What will we do when we have like terms? How? Are we going to add or subtract if we have like terms?
Add.
We're going to add. So, 16, we could have 1 and 16. We could have 2 and 8. 3 won't go. 4 and 4. So, two factors that equal 16, that when you add, you get 10.
8 and 2.
Yep. Which could be x minus 2, x minus 8, either way. All right, you finish the page, the front, 4, 5, 6, 7. Oh, help me super quick. List the factors of 36.
6.
So 1 and 36, let's list them in order. Will 2 go?
2, yeah.
2 and what?
18.
18. Will 3 go?
Yes.
Yes. 3 and what?
12.
12. 4?
No.
Yes.
4 and 9.
4 and 9. 5?
Nice try.
No.
6?
6 and 6.
6 and 6. So then we're repeating. We're starting over. So you need to look at all of those to be able to work 5.
I like this one.
This lesson?
Yes, ma'am.
I do too. Factoring is fun. It's so like a puzzle. Just wait till we throw in lead coefficients that aren't one.
Wow.
It just gets more like $1,000 piece puzzle. It's fun, fun, fun. So number 4, two factors that equal 6, that when you do what to get 7?
1 and 6. 1 and 6.
We're going to add. So everything's positive.
Wait.
Now you could have said plus 6 plus 1. That doesn't matter. Now, two factors that equal 36 that when you add to get 20.
2 and 18.
Yep. And I don't always think of 2 in it. When I think of factors of 36, I usually think of 6 and 6 and 9 and 4.
Does it
Some-
matter if it's the other way?
Nope.
Okay.
Plus 18 plus 2. So it's good to always list all the factors to help you find which one it is for 20. All right. This one's super easy. Factors that equal 9 that when you add, you get 6. Yep.
3.
And then the next one, 20. Yep. Do you remember what we call the last two? They have special names.
Perfect square trinomial.
Yes. Perfect square trinomials. Excellent. All right. So we're going to move to the back. Notice the last
Negative.
is negative. How do you multiply to get a negative?
Positive. 2 different.
Yeah, they're going to be different, which means if they're different signs, do we add or subtract to get the middle?
Add.
We're going to subtract because if you have different signs, you're not going to combine them by adding.
So would you subtract though?
So we're going to list the factors of 18. Super easy. 1 and 18, 2 and 9, 3 and 6, 4 and 5 do not go, and we're back to 6. So, same process. Factors that equal 18, but in this time, we are going to subtract to get 7. Which factors?
9 and 2.
Yep. Now, when you're subtracting, how do you know what the sign is for your answer?
Oh, the bigger numbers.
The bigger number. You got to keep that in mind when you're working this. This sign right here, the first one, tells you what the bigger number's sign will be. So it's going to be x minus 9, x plus 2. And then if you FOIL, you'll get 2x plus negative 9x, and that gives you your negative 7x for your outer and inner. And then your last gives you your negative 18. So what do you think number 9, two factors that equal 12, that you, when you subtract, you get 1.
3 and 4.
Excellent. Which one? What?
Negative 3.
Negative 3, positive 4. Good. Because it's a plus 1x. So the larger number needs to be positive this time. All right, you do number 10. Remember, you're subtracting, not adding to get 5. So be sure you use the correct set of factors. So what did you get for 10?
I did.
X plus 6.
X plus 6, x minus 1. If you had used 2 and 3, that adds to get to 5. But it subtracts to get to 1. And so that doesn't work. But the 6 and 1 would work. Did that make sense?
Yes.
All righty. 11. Don't let this throw you. First, you know, is going to be your x squared. So we're going to break that up into x and x. Where is that y squared located?
At the last one.
It's in the last area.
Yeah.
So it goes in the last part of the binomial. So we'll throw that y in right there and right there. And now you just work it. Two factors that equal 16, that when you subtract, you get 15. And which one's going to be positive, Lane? The 16 or the 1?
The 1. 16.
This is Lane's problem.
Oh, sorry.
it's a plus 15, so we need the larger number to be positive.
So 16.
16. Mhm. Now you could just say x minus y. You don't have to have the 1y in there, okay? Just so you know. You work 12. So, two factors that equal 28, that when you subtract you get 3. 7 and 4, which one's positive?
7.
The 7. Oops, I put minus 3. There. Are we good? Is it making sense? Anybody need a further little explanation?
For, it says a squared plus 3ab. Do we ignore the a? For like,
All right, when we FOIL.
okay.
So we're going to go a times
Uh-huh.
a squared. And then for outer, a times negative 4b. So that gives us negative 4ab. And then your inner gives you a positive 7ab.
So it like,
So they just come magically morph together.
okay.
Yeah, you don't have to try to bring in a variable. And let me say this too, Parker. If you end up with BA, that's the same thing as AB. Commutative property lets you change the order of the variables. And normally we go alphabetized. So AB, AB. I mean, that would give you your positive 3AB. All right. GCF first is what it says. So 13, what is the GCF?
2.
2. What's left behind? Plus,
7
plus,
Plus 6.
yes. So then you say two factors that equal 6, that when you add you get 7.
1 and 6.
1 and 6. I want to call your attention to this. If this had been 2n squared plus 14n plus 16. Okay, I'm just making up a problem. We would have removed the 2 as the GCF, right? And we would have had n squared plus 7n plus 8. Agreed?
Yeah.
All right. This is asking us, name two factors that equal 8 that when you add, you get 7. And we have 1 and 8, and we have 2 and 4.
There isn't one.
Ha ha ha. There isn't one. That's as far as you go. Excellent.
So that's your answer because you can't do it.
This would be your answer. And hear this. Let's say you were given n squared plus 7n plus 8 as one of your original, like that was the problem. No GCF removed. You would have to write prime for this. There are no factors that are shared. Nothing can be broken down. We can't find factors of 8 that add to get 7. So you would just write prime. Okay? If you can't work it, don't let it freak you out. All right, 14. What do they share?
3.
3. What are we left with?
Y squared plus 10y plus 8. No, it's not.
plus 9. 2 factors. You finish it. Y'all work it. What would the final answer be?
Y plus 1, Y plus 9.
Yep.
So when there's still a greatest common factor, you keep it there?
I was just about to address that. Thank you, Caroline Louise. Absolutely. Because when you finish and you want to check your work by foiling,
On it wouldn't work without.
you would only have y squared plus 10y plus 9. You would not have the 3y squared plus 30 plus 27. The only way you get back to that all the way is to distribute the 3.
Okay.
So if you, and I will say this, guys, on your quiz, not on Thursday, because we're not doing this on Thursday, but you'll have a quiz the next time around. If you mentally remove the greatest common factor and do not list it, I will not give you full credit. And if you don't have it listed in your answer, I still won't give you full credit, even though maybe you worked it somewhere up there, but you didn't put it down with your final answer when you box it in, okay? Be doubly sure you include it. You do 15. It's not as crazy as you might think. Is there a GCF?
Yeah.
What?
D.
Yep. It sounds like really big. We've got factors of 70. That when we subtract, we get 3. I mean, that just sounds crazy. Who knows what it is?
10 and
Baxter?
7.
Yeah, 10 and 7. What's Baxter? What takes the negative?
Is it the 7?
The 7. No,
Oh.
the 10. The 3 is negative, so the larger number has to take the negative. So 10 is D minus 10. D plus 7.
Would it be wrong if you said D plus 7 and then D minus
No,
7?
community property. Yeah, we've talked about that. Community property is great. It allows you to go either way. Now, when we move into greatest lead coefficients that are not 1, it matters. The placement of everything
Wait,
matters.
aren't those lead ones without?
These are all having a lead coefficient of 1. When you remove the greatest common factor, you're back to a 1d squared or 1n squared.
But how would
No.
you do it without using greatest common factors?
Come back to class. It's still the same process, but you got to factor out the first coefficient, factor out the last coefficient, and see how the puzzle comes together.
Yes.
Yeah, it's loads of fun. All right, that's the end of the lesson. Let me get your